Hi, my name is Stanley Wong. I'm gonna talk about schematic for circuit 1. Okay, so this is the schematic for the circuit 1. For this circuit, we only use one IC, which is the NOR gate. So I'm gonna prove the theory now. So as you can see, when A is 0, B is 0, the output is 0. When B is 1, the output is 1. When A is 1, the output is 1. When A and B are 1, the output is 1. So we can conclude that the truth table for X is A plus B, which is the OR gate. This is the schematic for the circuit 2. This is the NOR gate and this is the AND gate. We use this switch modular as the switch of these two gates. This is the switch A and this is the switch B. And we use, to prove the theory, we use the LED modular. Okay, so now we're gonna prove the theory. So as you can see, when A is 0 and B is 0, the output is 0, like no light. So when B is 1, the output is 1. When A is 1, when A is 1, the input is 1. Okay, so when both input is 1, the input is 0. So we can conclude that the truth table is exclusive OR.
Okay, so for the part 2, the circuit, the input is set to 500 kHz and then it's connected to the channel 1 of the oscilloscope. For the output, after the series of 4 NAND gates, and then it comes to the channel 2 of the oscilloscope, and this is the waveform we get. For the Vmax of the channel 2, we get 4.08 volt, and then the minimum we get negative 480 millivolt. So for the TP-LH and the TP-HL, we get TP-LH is around 50 nanosecond, and then the TP-HL around 30 nanosecond.
So now I'm gonna talk about part 3 of lab 1. As you can see, we set up the circuit based on the diagram. And because there's a NAND gate, we connect the inputs into the NAND gate. Then after that, it will go across the NAND gate, then go to the resistor. After resistor, we connect the LED. Then at last we connect to the VCC, which is the VDD. Based on our calculation, it is 103 ohm, so we use 120 ohm because we don't have 100 ohm resistor. So as you can see, when the input is 0, the LED doesn't light up, but when the input is 1, the LED lights up. That's all. Thank you.
I'm Chua Wei Long, and then I would like to talk about part 4, schematic diagram. There are 3 inputs, input A, B, and C. And then there is a quad 2 double input NAND gate and a 333 NAND gate, which consists of 3 input, and then there's 1 LED. So for the requirement is when 2 or more input go high, and then the LED will light up. So when A is 1, there is no LEDs light up. When B is 1, also no. When C is 1, no. And then for when A and B is 1, the LED turns on. For A and C 1, the LED turns on. And then for B and C 1, the LED turns on. At last, when 3 inputs goes 1, and then the LED turns on. That's it.